Hey there, this is the 7th C# tutorial here. It's been nearly 2 years since I last made a C# tutorial, so it's been a long wait. So today I'm going to be going over class inheritance and interfaces, and both these are very, very useful for essentially extending existing functionality or being able to abstract functionality. So both those things might seem, so I'm going to explain what those, how that works, and the benefits of, inheriting from a class or using interfaces. I'm going to try my best to condense both class inheritance and interfaces in the same video lesson, and I'll see how well I can, execute that, because both of those can also have their own, I think, are subjects of their own as well. But I'm going to try and condense those into just one video. So we're just going to make a console application. Let's call it inheritance versus interfaces. I'll just call it. So first we're going to cover class inheritance. So with class inheritance, what that basically is you're taking an existing class and all of its functionality, and then you're adding new functionality on top of that class's functionality. And what this lets you do is essentially lets you make a superset of existing stuff, and it's something that's very, very powerful. So first thing we're going to do is we are going to make a class. So let's click add new item, and we are going to call this, we'll call it base class. This is a very poor name to give a class, but for demonstration purposes I'm calling it base class. So here's our class, base class. So far has nothing. So let's add we'll add a few methods. So I'll say public void some method, and some method will output some text to the console window. And then now I'm going to wait for Visual Studio to catch up with me because it's frozen. And even more frozen. Okay. So this method will write something to the console window. So maybe some method writes, actually, you know what? We'll call this we'll make 3 methods here. So front bracket. We'll call this front bracket, and front bracket will print out that. And then we will make another method called, text. And text will allow a string parameter. So we'll have that. And then we'll add another method called ending bracket, and we'll have a closing bracket here. So now we have these three methods in our base class. And if we go into our program, we've built a class, so we make a new base class is equal to new base class, right? So we've gone over classes, we know what those do, and I'm just gonna quickly go over this. So we have our methods here: front bracket, ending bracket, and that. So be logical just to do front bracket, then base class dot, dot text, so now we've got our basic program, and we're going to put a console.readline to make sure this doesn't close on us. So now when we run this, we just need to make sure our base class is working, of course, and our program works. And actually, what we can do is I'm just going to quickly change this so everything's on one line. And that will be perfect. So there we go. We got our basic program. So we are going to, now we can get to the actual showing you how class inheritance works. So we have our base class, which has three methods: front bracket, text, and ending bracket. And we are going to make a class that inherits from base class. So we'll call this base class extender. Again, a very horrible name for a class, but for demonstration purposes, I'm giving it that name. So this is a new class, and we want this to inherit from base class. So what we want to do is we want to go to where the base class, where the class name is written, right? And we're going to put a colon here, and then I'm going to write base class. So this is how we tell C# that we want this class to inherit from base class. And we're going to add another method here, public void. And what's something different we could add? Well, maybe we want to have a method that outputs a colon. Oops. Okay. So you'll make a method called colon and console.write, and it will print a colon. And we'll add, maybe one more method that does something. We'll make another one called dash. And maybe make a third method called white space. So now we have a class that extends base class and adds functionality on top of whatever is in. So base class extender will basically extend the functionality that base class has. So it's taking the methods and structure of base class and putting its own components over top of that as well. So pretty much it's like me saying I am a human. I have all the attributes of a human, but I am a police officer. And as a police officer, I have these duties. So you're adding something on top of a base thing. A job description can be applied over top of a base, person. So one more time to explain this. We have all this functionality in base class. We have a method called front bracket, a method called text, and a method called ending bracket. So we have a class here with all these methods. We can take the functionality that base class has and attach it to another class. And this class implements these three methods. And this class will have these three and because of this class will have its three methods that we defined plus the methods defined in base class and the properties defined in base class, and anything that was declared in base class is going to be a part of this class as well. And we're going to have this stuff that we've put into base class extender, our class name. All that is going to be, alongside of all that stuff. So now we have base class extender. So I can say base class extender, and I'll just call this method extender is equal to new base class extender. So I'm going to now compile this, and as you can see it works even though I changed the data type. But now with our new class we have more options. We have the ability to use a colon method, ending bracket method, front bracket method, text method, white space, and a white space method. So now let's do something with these methods. So we're going to use the So maybe I'll say stats report. Maybe I'll write here. And then extender dot white space extender dot colon. Actually, we'll just swap that over. And then So now, if we run this code, we have this here. And just going to fix something quickly here. So I'll take this and there we go. So it says stats report, 56 people are people, 23 dogs are dogs. And so this covers class inheritance, where we took the functionality of a base class with these three methods, and we created a new class. And this class took everything that's in this class and also implements its own functionality over top of the base class, the existing functionality of base class. And another trippy thing you can do is we can make a class that inherits from base class extender. So if we make a class that inherits from base class extender, it will have everything that, it'll have all these methods, plus all the functionality in base class, plus any new functionality that it implements. So class inheritance is a very powerful thing. The next thing we are going to get into is interfaces. So interfaces are interesting. So let's pretend like this doesn't exist. And let's pretend that that doesn't exist anymore. What I'm going to do now is base class is instead now going to be an interface. So to declare something as an interface, we use this interface type here. So now this is an interface. And with an interface, you cannot make blocks of code, really. It's for defining with an interface, you're defining a structure for another class to follow. And this is useful for extracting functionality that you yourself aren't going to implement, but any class that uses your interface must implement. It allows you to make more assumptions. Now, interfaces are can be very tricky to understand, because they are meant to abstract things. They are meant to make your code as dumb as possible. And with object-oriented programming, the goal is to make your code as dumb as you possibly can make it, because dumb code is easier to debug and easier to fix, and interfaces let you dumb things down to like the 9th degree or the 10th degree. So here we've made an interface called base class. So we want to define what another class must implement if they want to use this interface. So I'll just say void. What were our methods here? So we had void front bracket, void text, void colon, void white space, void ending bracket, and yeah, I think that was all it. So we now have a interface. And it says we must implement these methods if we are to use this interface. And another thing too is I'll actually rename this. I'm going to call this I interface, if that isn't a taken name already. I demonstration interface, I'll call it. When you are dealing with interfaces, it's standard to put an I in front of the name. And this tells anybody who's reading your code immediately whether or not something is a class or if something is an interface. So we'll just call this class interface user. Again, a very bad name for a class, but for demonstration purposes, this is what we're gonna do. So to implement our class, our new interface, we are going to again use this colon here, and we are going to use our new I demonstration interface. So the first thing that's going to happen is we're going to get errors. We're going to see errors saying that our class does not implement certain things. For example, it says does not implement interface member. It's inheritance versus interfaces.interface user. Does not implement interface member inheritance versus interfaces.iDemonstrationInterface.whitespace. What this means is we, in our interface, we have this stuff here defined, but this class here, it has neither implemented. So now I'm going to re-explain what an interface is. An interface defines a structure that your class must have. And what makes an interface powerful is an interface just gives a structure and it doesn't provide any functionality. But by using interfaces, you are able to make more assumptions, and it allows you to abstract your code to the point, to a very, very, very dumbed down point, and it makes your code easier to debug. It makes it easier for you to transition technologies, a whole bunch of benefits using interfaces. So basically, an interface is a way of dumbing everything down. It's a blueprint of what you want to do or how things should be, but it doesn't actually provide any functionality. So now I have to implement the interface. So if we want to fix some of these errors we have here, we're going to right click iDemonstration Interface, and we're going to click Implement Interface. We now have all these methods here, and by default they are filled with this thing saying throw new not implemented exception. We are going to replace these with whatever code we had before. So front bracket was the front bracket. Text. The code for colon. And there we are. We've got our class here. And now we are going to So now we have our new class that uses this interface. Okay, so we forgot one. I'm going to add a method for dash. And erase all my code by accident. So we also have to implement dash here. And there we are. Our code will compile, and here's our code. So again, you might be wondering, what benefit do we have from inheriting from something called iDemonstration interface? Why the heck did that matter? In what situation am I going to need an interface? You might be thinking, all we did was we defined a bunch of stuff here. We defined a structure here. And we copied that structure here and had to rewrite functionality for every single method that was defined in here. And it's now all, instead of being in two files in two files or split between two different classes, like we did in the example of using class inheritance, now we have to state everything in one file. And you might be thinking that this is just redundant. But again, I'll explain it again. It allows you to, by defining a structure, this lets you make more assumptions when it comes to dumbing down your code. And this is why interfaces are such a, can be a interesting thing to try and learn, because it's all about dumbing down your code, but the application for an interface may not immediately seem useful. So where the heck would this be useful is the question. So one thing with interfaces is, or one of the differences between an interface and an inheriting from a class, is that with an interface you can essentially with interfaces you can implement many of them. So with class inheritance, you can only inherit from one class, but you can implement multiple interfaces. So let's make a new interface. We're gonna go under Add, New Item. We're gonna create a new interface. And we are going to name this interface interface number 2. Again, a very bad name for an interface. But again, this is for demonstration purposes. So, what other functionality could we have for outputting? So, void period void. So void period, void comma, and void I'm trying to think here. And void quote. So now we have a second interface. Now, if we want to implement multiple interfaces, what we do now is, after we have one interface, or if there's a class or whatever there, to say that we want to inherit from another interface, we put a comma here, and then we type in our new interface. So now if we try to compile, we're going to get a compile error saying that this class interface user does not implement our quote method, the period method, and the comma method. So we'll right click this and we'll click implement interface. So we'll have these two new methods added here. And we'll write in the code for this to work. So console.write so a period console.write a comma console.write in the brackets for our colons there, and just gonna add one more symbol there. So now we have added functionality, and if we go to our program, we can add these extra symbols. So extender dot period So now, what's something really powerful? Well, we inherit from two classes. Or no, we implement two types of interfaces. And because we implement two types of interfaces, we can do an interesting thing. So we have demonstration interface, and we'll notice that when we declare demonstration interface, we get an error here saying that our extender does not contain a definition for quote, and no extension method quote accepting a first argument type interface versus interfaces dot demonstration interface could be found, or you're missing a directive or assembly reference. So I'll show you an example of what inheriting from two interfaces lets you do, and why this becomes a little more useful. You can make certain decisions based on what functionality exists. So first, let's we'll say interface user, user. Okay, we'll have to go back. I'm going to go back here to see what our class name is again. Interface. Oh, I spelled something wrong. So I'll add an R back in there. Now that should be fine. So interface user is equal to new interface user. And then what I can do is I can say demonstration interface demonstration, and I'll call this user I'll just call this user demo 1. Again, this is a bad name for a method, but because this is demonstration purposes, you know, just trying to get the point across. So we'll say that this is equal to user. And then I'm going to say that interface number 2 is equal to use. So interface user 2, I'll call this user demo 2 is equal to user. And then I'll fix up the rest of this. So user demo 1 actually, I'm just gonna do this. Oops. So now we're going to have 2 instances where this doesn't work. Actually, there should be 3 instances. So I'll just add another one. So user demo 1 does not support a quote because user demo 1 is of type iDemonstration interface, and iDemonstration interface does not have the method quote in its structure, but in our interface called interface number 2 does. Same with period. User demo 1 does not have a definition or does not have the method period defined in it. Therefore, we cannot use the method period. But our interface called interface number 2 does have a method for period. So it's going to work. So by using interfaces, we're able to essentially treat interface user as multiple types of data, and it can be stored as within many different structures. Because it implements iDemonstration interface, it can set a variable of type iDemonstration interface. Because interface user also implements an interface called interface number 2, we are also able to store our user variable as that interface as well. So interface user is able to seamlessly be set to other types without any sort of casting. And if we compile our code, you can see that our code does work here. So hopefully I was able to explain everything, with enough depth and whatnot. If there's any unanswered questions with this, I'll try my best to, answer the questions and make this more clear. I'll show an extreme example here of a program I've been working on where I use nothing but interfaces. It'll be overwhelming to look at in terms of code, but hopefully I can, draw a picture of why interfaces, or what makes interfaces very, very important in certain cases. You can definitely survive never using an interface structure, but they're very useful for if you don't want to have things 100% set in stone. Because with an interface, you're saying you have to have meet this criteria to implement me. and I don't care what code you have inside of whatever structure I told you to make. But as long as you have those items, you fulfill this contract of items, you can implement me. And by implementing me, you can cast yourself to different types with ease. And I can make assumptions and you can make assumptions that certain methods will be in a class because it implemented a certain interface. Now, one example of something like that would be, I know animals have legs. And I know that animals eat. And I know that animals drink. But I don't know how. But I don't know how every animal eats. I don't know how every animal drinks. I don't know how every animal walks or how many legs they have. So I make a structure for an animal, but I make it up to the person using the interface to define how a specific animal will eat and how a specific animal will walk and how many legs it has and all this other stuff. So in my advanced case here, I have a bunch of project files here. Each project file here there's actually another thing that I'm not going to go into, but if you've ever been used to plugins, my program here is plugin based, and I use interfaces to abstract things. So if I click run here, this program will run. And it's loading up compiling all the projects. And then I have this pop up. Now the thing with this program is it has no clue at all that it's using Windows or that it's running on Windows. And how the heck can you have a program run on Windows and have it not know it's running on Windows? Well, because I've used interfaces. By using interfaces, I'm able to make my program not care about what operating system it runs on. All it does is executes actions, and the implementation of those actions is done per platform. So, for example, if I go back here, if I click a button, it sends a button event. And I have a wrapper around a button which says, hey, this button had a button click event. I'm going to send this to a different button click event that I was told to implement, and then that event will be triggered in code that has no clue about the Windows events or what's going on in Windows. So again, interfaces are kind of hard to, explain without completely being confusing. So I apologize if what I'm saying doesn't 100% make sense. So let's see, where's a good example I can find here of me using an interface. Okay, so here's a perfect example. If I go to this main form class here, if you've ever looked at the designer code for WinForms, this should be somewhat familiar. But here is an example of an interface I've done. So here I'm saying this.panel1 is equal to factory.buildPanel. So what the heck does this mean? How does this illustrate an interface? Well, if I right click build panel and I click go to definition, I'm brought to this page here. And what is this? This is an interface called iFactory. iFactory has all these different methods in it, or at least is defining these methods. And over here, I'm calling these methods that are defined in that interface. But of course, another thing to note with the interface is that you cannot initialize, you cannot create an instance of an interface. You just can't. The only way you really can create an instance of interface, well, actually, that's wrong. You can't create an instance of an interface. If you want to set an interface, like if you have a variable that's of a type that's an interface, if you want to, initialize that variable, it must be set to a class that implements that interface. So an example of that is, okay, this is called factory.buildPanel, or here I'm saying I want to build a panel, and it's calling a build panel from a variable called factory. Well, if I go into one of my other projects here, which would be Win32 Factory, and I go into my wrappers, and I look for build panel here, if I can actually find it. Oh, panel wrapper. Actually, no. Win32 Factory. So if I go into here, I have a class that inherits from, I have a class called Win32 Factory that inherits from factory, or iFactory. And this is the structure of iFactory. So, if I go into here, and I look for our build panel, here is our structure. So this is returning something called a panel wrapper. Now, panel wrapper is a class I made, and if you go down to panel wrapper, we'll see that panel wrapper inherits from a class called control wrapper and implements an interface called iPanelView. So panel wrapper is pretty vague as well. So if we want to check out iPanelView, which is an interface as well, whoops, I right-clicked the wrong thing. So if I go into iPanelView's interface, it has nothing in it. But here's an interesting thing. We see that iPanelView implements iView and ContainerView. But here's the thing with an interface. When an interface implements another interface, you don't define anything. Because in an interface you can't define logic. You can only define structure. So what will happen is the contract written for this interface and the contract written for this interface will merge with the contract for our iPanelView, which means that once we get to this point, we're going to have to implement structures from both the interfaces defined in iPanelView. Hard to simplify, what I said there, because with interfaces it gets really wonky, especially if you try to rush the understanding of what an interface is. So if you want to go take a look here, if we go into iContainerView and we look at its stuff, we see that it defines two properties. It has it defines a structure for these other methods here. if we go back to iPanel view and we check out what's in iView, here's everything that's in iView. And if we go back to iPanel or our Win32 factory, or panel wrapper has methods here that match that structure. One thing that's nice is that they're separated too, so we see our members for our iContainer. Oh, interesting. But yeah, we see that we have methods here that fulfill the contracts of both iContainer view and iView. So iPanel view is pretty much just an interface that's merging these two contracts together, plus whatever contract it defines, which iPanel view doesn't have any structure that it's defining. So the structure of iView and container view are just being merged together with an empty contract that panel view declares or has. So if we want to go through here even further, we also see that we have a thing here called control wrapper. Obviously this can't be an interface because it doesn't have an I in front of its name. And if we go into control wrapper, what's this? Control wrapper inherits from iView. So it's interesting, you get some redundancy here. Control wrapper inherits or implements iView, and iPanel view implements iView, which control wrapper also implements, and it also implements iContainer view. So you can have overlap with these interfaces as well. The compiler is not going to complain at all. Like, there's no problems if you have some redundancy with your interfaces. And then control so yeah, that's pretty much it here. And so control wrapper, what does it do? Control wrapper wraps around a WinForms control in this case. And all that other stuff is, you know, specific to the program, and I'm not going to go over what my program does here or anything. I'm just going over the structure of an interface. So that's pretty much everything I have to say about interfaces. If you have any questions, concerns, I'll be able to try my best to answer them. Interfaces are a very, very, very or can be a hard thing to wrap up your head around. But if you're pretty good with data types already, interfaces are great for abstracting the crap out of everything. Like, for me to have a program that has no clue it's running on Windows because I decided to use interfaces is just phenomenal. So yeah, again, thanks for watching, and I hope this helps you in trying to use interfaces.